Well, good morning, ladies and gentlemen. I am trying to record at home, so this should be interesting. We'll see if my young dog can refrain from barking enough for me to actually get through a lesson. We're going to be reviewing factoring from Algebra 2 because we are going to have to factor trigonomic expressions in order to simplify them. Okay. The very first step, always, 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 is look for a greatest common factor. Make sure you are looking at both the numbers and the variables. You're then going to divide every term in your expression by the greatest common factor. And you're going to write your answer in the format of the greatest common factor first, the leftovers in the parentheses. Okay, it's really bad to try to write a greatest common factor at the end of an expression. So let's take a look at this one. And even though I closed my dog out of the room, he's let himself back in. Between 12 and 10, my greatest common factor is a 2. And between a cubed and a squared, it is a to the second power. Now, when you're dealing with a variable, you always take the variable to the lowest exponent as your GCF. All right, parentheses. I need to divide each of these by this greatest common factor. 12 divided by 2 is 6, and a to the third divided by a to the first is a squared, plus 10 divided by 2 is 5, and a squared divided by a is a. That's as far as we can go with this one. Go ahead and try the next one on your own. Pause the recording and come back to check your work. All right, between 14 and 7, my greatest common factor is a 7. M to the 8th and m squared, I want the smaller exponent, so m squared. N to the 5th and n to the 2nd, smaller exponent is n to the 2nd. And I'm going to divide each of these terms by this greatest common factor. All right, 7 m's, n's. Can you hear him panting? 14 divided by 7 is 2. M to the 8th divided by m to the 6th m to the 2nd is m to the 6th. N to the 5th divided by n squared is n to the 3rd, minus everything canceled from this expression. That doesn't mean we have a 0. It means we have a 1, right? 7 divided by 7 is 1, times m squared divided by m squared is 1, times n squared divided by n squared is 1. And 1 times 1 times 1 is 1. Don't lose this term at the end of your expression. All right, the difference of squares actually comes from Algebra 1, and you need to memorize your pattern. All right, it is a squared minus b squared, and this is going to equal the square root of the first in the front of the parentheses, the square root of the second in the back of the parentheses. One has to be addition, one has to be subtraction. So let's do a couple of these. All right, I don't have a greatest common factor, so I'm going to go straight to my two sets of parentheses. The square root of 9 is 3, and the square root of x squared is x. The square root of 49 is 7, and the square root of y squared is y. One has to be addition, one has to be subtraction. All right, as I look at number 2, I do have a greatest common factor of 2. And this is going to leave me with 36c to the 4th minus 1. Now, I know 36 is a perfect square, and I know 1 is a perfect square, but what about that c to the 4th power? So let's go back to what square roots mean, your exponents and radicals unit. The square root of x can also be written as x to the 1/2 power. So the square root of c to the 4th can be written as c to the 4/2, which is c squared. So yes, I can take the square root of c to the 4th power. In fact, you can take the square root of any even power. Sorry about the barking, guys. Nothing I can do right now. So we are going to keep our greatest common factor and set up 2 sets of parentheses. I locked my dog out of the room again. Hopefully this will let me get through the lesson. The square root of 36 is 6, and the square root of c to the 4th is c squared. Square root of 1 is 1. 1 has to be addition, 1 has to be subtraction. Let's look at the next one. I have a greatest common factor of 7. It looks like m to the 1st and n to the 1st. So let's divide. I can hear him barking out the door now. All righty, m to the 7th divided by m is m to the 6th minus 4n squared. So let's think about this m to the 6th for the minute, right? The square root of m to the 6th power is going to be m to the 6th divided by 2, which is m to the 3rd. So I have 7mn, m to the 3rd plus 2n, m to the 3rd minus 2n. All right, pause your video and try this one on your own. Then come back to check it with me. We have a greatest common factor of 10w. And when I divide both of these by 10w, I get w to the 4th minus 1. All righty, I've already dealt with a 4th power before. I know this will be 10w, w squared plus 1, and w squared minus 1. Now, there is nothing I can do about the plus 1 because something squared plus 1 is prime. But this one right here, this is another difference of 2 perfect squares. So my final answer is going to be 10w, w squared plus 1, and this one factors to w plus 1, w minus 1. Isn't that cool? You can do it more than once. So picking up in another location to try to finish this video, how do I factor the sum of cubes? Well, this is a pattern that needs to be memorized, just like the difference of squares needs to be memorized. This one, however, was taught last year in Algebra 2. If you have a cubed plus b cubed, this is going to factor to a binomial times a trinomial, okay? We want to take the cube root of your first value. Now, just like with square roots, a cube root can be written as an exponent, and that exponent would be 1/3, right? So 3 divided by 3 is 1. So the cube root of a cubed is a. Take the cube root of the second term, and this is going to make up your binomial. Now, ignore the original problem and focus only on what you just did. You want to square the first term, you want to multiply the two together, and you want to square the last term. This gets you the basics. Now we are going to apply SOAP. Same, opposite, always positive. So this was addition, same, opposite, always positive. Okay, that's our pattern. Let's take a look at a couple of practice problems. All right, there is no greatest common factor, so I'm going to have a binomial times a trinomial. The cube root of x cubed is x, and the cube root of 27 is 3. Now, if you don't have your perfect cubes memorized, or you get a number that's just a bit on the outrageous side, on your graphing calculator, go to Math, arrow down until you see cube root. Press Enter, type your number, close the parentheses, and press Enter, and your graphing calculator will find the cube root for you. I ignore the original and I look at what I wrote. Square it, multiply them together, square it, apply SOAP. Same, opposite, always positive. All right, let's try the next one. No greatest common factor, so it's going to become a binomial times a trinomial, right? The cube root of m cubed is m, and the cube root of 216 is 6, and then we'll have an n. Ignore the original problem, square your first term, multiply them together, square your last term, should have left myself just a little more space there, and apply SOAP. Same, opposite, always positive. All right, my next one had better have a greatest common factor. Even if I don't have my perfect cubes memorized, I know 4 is not a perfect cube. So let's see. If I take out a 4 from both terms, I am left with 125a cubed plus 1. All righty. So 4, binomial, trinomial. Let's take a look. The cube root of 125 is 5, and the cube root of a cubed is a. The cube root of 1 is 1. Square my first, multiply them together, square the last, and apply SOAP. This is my final answer. All right, go ahead and pause your video and try the next one on your own, then come back to check with me. All right, I definitely have a greatest common factor, and I'm thinking 3CD. So if I divide both terms by 3CD, that will give me 8, and that's how I decided on the 3. What perfect cube was a factor of 24? Okay, c to the third power, the d's cancel out, plus 125, c's are gone, d to the third power. All right, so this is going to be 3cd, binomial, trinomial. Cube root of 8 is 2, and cube root of c cubed is c. Cube root of 125 is 5. Cube root of d cubed is d. Square the first term, multiply the two together, square the last term, needed just a little more space there, and apply SOAP. This is my final answer. Ideally, parentheses out here. Okay, so now let's look at the difference of cubes. And the good news is that it is the same pattern. So we need to memorize this. And we're going to have a cubed minus b cubed this time. We're going to take the cube root of each term, and then we're going to ignore the original problem. Square the first, multiply the two together, square the last, and apply soap. Okay, applying soap changes the signs, and that's what would make this come out a cubed minus b cubed. So let's take a look. No greatest common factor. And my cube roots were very obvious, which was kind of nice. Square the first, multiply them together, square the last, apply soap. Same, opposite, always positive. Okay. No greatest common factor again. So cube root of 216 is 6. K cubed becomes K. 125 becomes 5. Square the first. Multiply them together. Square the last. And apply soap. All right, for number 3, I had better have a greatest common factor because 4 is not a perfect cube. And if I pull 4 out, I get 1 minus 8h cubed, which is awesome. So let's see. Cube root of 1, cube root of 8, cube root of h cubed. Square the first, multiply them together, square the last, apply soap. Go ahead and pause your video, try the next one on your own, and then come back to check it with me. Alrighty, I do have a greatest common factor here, so we've got to pull that out first. X cubed minus 27y cubed. All right, that's good because I know that those are all perfect cubes. Cube root of x cubed, cube root of 27, cube root of y cubed. Square the first, multiply the two together, square the last, and apply soap. Final answer. All right, so those are the special cases that we're dealing with. What if we're just dealing with a pure trinomial? All right, so I'm going to walk you through this step by step. And we're going to do our example where a is not equal to 1. When a is equal to 1, it's a lot quicker to factor. But when a is not equal to 1, we've got a few more steps. Step 1 is to multiply a and c. So 9 times 4 is 36. Then we want to find all the factor pairs of our product. So 1 times 36, 2 times 18, 3 times 12, 4 times 9, 5 doesn't work, 6 times 6. Now, if finding the factor pairs is a challenge, you can use your graphing calculator to help you with this too. Go to y equals, type your number divided by x. Then press second graph, which takes you to the table of values for this function. And it will list all of the factors. If a number is a decimal, like 5 into 36 is a decimal, then that clearly doesn't work. But it is a way for you to generate the factor pairs quickly if that's not a strength. All right, we're going to determine the signs of our factor pairs. When AC is positive, both factors have to be positive or both factors have to be negative. A positive times a positive equals a positive, and a negative times a negative equals a positive. So we check B to determine our signs. When I look at B, in this case, it's negative. So that means both factor pairs have to be negative. Let's say, for example, that this had been a negative 36 when I multiplied it, okay? Then I have to have one positive and one negative, because a positive times a negative is a negative, and a negative times a positive is a negative, right? We would check B for the sign of the factors, and if B is negative, your larger factor has to be negative. If B is positive, your larger factor will be positive. We'll have a couple of those on the next page. So now I want to decide which factor pair adds up to B. And it's negative 6 plus negative 6 will give me 12m squared. So let me copy the problem down here again. 9m to the fourth minus 12m squared plus 4. Okay, I want to rewrite my trinomial, splitting the middle term. Using the factor pair I selected. So I'm going to keep 9m to the fourth, but negative 12m squared becomes negative 6m squared and negative 6m squared. I will keep my plus 4. Okay, so I'm splitting that middle term, and I just realized you can't see it. I'm splitting that middle term into two parts. Now I'm going to split my polynomial into two pairs. I'm going to cut it in half. And I'll factor the greatest common factor from each pair. So when I look at this first, the left half, 9 and negative 6. Well, my greatest common factor is 3. M to the fourth and m squared is going to be m squared. And this leaves me with 3m squared minus 2. When I go to pull the greatest common factor from this side, if your first term is negative, you've got to pull a negative. You have to have the exact same value. CT would help if I could spell. In both sets of parentheses. I need a positive 3 to be in the parentheses over here. So I'll pull out the negative 2, and that'll give me 3m squared plus 2. Okay, these have to be the exact same values, or something's gone horribly wrong. Okay. So for your final answers, the GCFs will go in one set of parentheses. In this case, we're going to have 3m squared minus 2, and 3m squared minus 2 are our leftovers, for lack of a better term. Now, for this particular one, I can go one step further. These two factors are exactly the same, so it is best to write them as 3m squared minus 2 squared. Now, this is the same process that you were taught last year. What is the difference between the way I approach it and the way most of the Algebra 2 teachers approach it? And the difference is here. Most of the Algebra 2 teachers teach you to draw an X, put the product up top, and B in the bottom, and then figure it out, okay? Play with it mentally until you come up with those two factor pairs. I like a more organized approach, which I'm sure you have all figured out by now, that I like step-by-step and logical approaches to things. I do not like to just noodle it in my head. So let's try some of these problems. All righty, no greatest common factor. So I am going to skip straight to two binomials. N to the fourth has to become n squared times n squared. It's the only way it's going to work. Plus, I need an n squared in the middle. Okay, there's no need to multiply a times c. A is 1. C is negative 24. So 1 times 24, 2 times 12, 3 times 8, 4 times 6, 5 doesn't work, and I'm back to 6. All right, to determine, one of these has to be negative, the other one has to be positive. To make that decision, I look at the middle, and the biggest factor is going to be positive. Smaller factor, negative. -4 and +6 will add up to a +2. So -4 plus 6. Oh, I should not have boxed this so soon. N squared minus 4, that's a perfect square minus a perfect square. I've got to go another step. N plus 2, N minus 2, and then I can keep my N squared plus 6. So this is the answer I should be boxing, not this one. Watch out for that. Anytime you've got a squared term, take a moment, take a look at it, see if it's possible to go further. If you have a cubed term, do the same thing. All right, as I look at number 2 has the greatest common factor. So I'm going to start by pulling out my W, leaving me with W squared plus W minus 20. Okay. So this is going to be W times 2 binomials. I know that W squared has to be W and W. Now it's up to this -20. 1 times 20, 2 times 10, 3 doesn't work, 4 times 5. Look at your middle. Your middle is positive. So the larger factor is going to be positive. Smaller one will be negative because a positive times a negative will give me a negative. To get 1, I want -4 and -5. It's not going to go any farther because all of those W's are to the first power. All right. Go ahead and pause your video and try number 3 on your own. Start with that greatest common factor. Okay, I'm going to pull out a 2a as my greatest common factor. And I will have a squared plus 19a plus 34. All right, this is going to be 2a, 2 binomials. And I know that a squared has to become a times a. So let's look at 34. 1 times 34, 2 times 17, and nothing else works, right? 2 is prime and 17 is prime. This is not going to break down any further than this. If I look at the middle, I can see that both factors need to be positive. Positive 2 and positive 17 will add up to 19. All of my a's are to the first power, so this is not going to factor any farther. I am done. Pause your video and try number 4 on your own. Okay, no greatest common factor. So I'm going to start with 3 times -5 is -15. 1 times 15, 3 times 5, and those are my only options. I look at the middle. The larger factor has to be positive. The smaller one will have to be negative in order to get a negative product. -1 and positive 15. So 3x to the 4th plus 14x squared minus 5. I'm going to keep my 3x to the 4th. But 14x squared is going to become negative x squared. And positive 15x squared Keep that minus 5. Cut this in half. Greatest common factor on the left is x squared, leaving me with 3x squared minus 1. Greatest common factor on the right is going to be 5, leaving me with 3x squared minus 1. Let's see if I put this together. Okay, x squared plus, nothing I can do to factor that binomial. X squared minus 1 is looking promising, but that 3 is not a perfect square. So I'm actually done. And there you go, ladies and gentlemen, factoring.